Alright, so hello everyone, welcome to another video, and today's video is going to be very important video of this entire Rust series. So I want all of you to stay focused, listen carefully and stay tuned till the end. So let's get started. So before moving ahead in this video, let's understand how memory works and what are the parts of memory that we need to focus on, and that will help us understand the upcoming topic in this video, right? So let me draw it for you. So imagine this is a memory and there are two parts in a memory, right? That is stack and a heap. So let me just name it stack, heap, and this is a memory. Let me drag it over here. Now let's understand each of them individually, right? So let's understand what a stack is. We'll color code it. All right, so let's imagine this is a stack. Okay, so to understand stack, you need to imagine, sorry, to understand stack, you need to imagine a scenario where a waiter is collecting a plates from the table, right? So what does it do? Let's say a waiter picks up a plate. Let me use a pencil over here. Yeah. So yeah. So let's imagine a waiter is picking up a plate. So the first plate it picks up, he puts on his hand or on a table or something, and now it moves on the second table, picks a plate, and he orders it on the top of the last plate, right? So it will follow that until all the tables are cleared, right? Picks up a plate, place on the top, picks up a plate, place on the top. Now, so the stack works in the same way. So this process of stacking up a plate on top of each other or storing a value in order as it received them on top of each other is called pushing, right? So we use a term called pushing onto the stack. Let me use a pencil over here. No. Yeah, and this process is called pushing, right? So if someone is saying that I am pushing a value on the stack, that means he is pushing a value on top of already piled up values, right? This is called pushing. And there is also a term called pop or popping. So what does it mean? It means that I am popping out the value from the stack, and it always follow an order of LIFO. So LIFO is last in first out. So you have to again imagine a waiter is handing over a pile of plates and distributing these plates on the multiple tables, right? So what does it do? That's very obvious that he will pick up a plate from the top and distribute to a table, then move to the next table, again from the top it distributes, right? So stacks also pop the values on the same way. It would be time consuming and dangerous act to pop out a plate from like middle or from the end, right? The plates can crash until you are a juggler. So a stack also pops up value in the same way. He pops out from the top. This technique is called, this entire process is called popping, and this process of popping out a variable from the top or last in first out is called LIFO, right? So I hope you have understand stack now. Let me revise it for you. Stacks store the value in the order it receives them and pops the value in a order of LIFO, right? Another example to imagine stack is, you can think of a stack as a magazine, right? So we push the values or bullets like on top of each other, and the last bullet that we have inserted will be the first one to go out. Now, an important point to be note over here is the data on the stack, right? So whenever we push values on the stack, their size must be known. So let's say you have an unknown size in a stack, then it can cause compile time error. So all the data that is going to be pushed on the stack must have a known size, right? So imagine you are pushing a bullets on the magazine, right? And suddenly you receive a sniper bullet, so it will crash, right? It won't be possible. So on stack, a data that we are going to store must have a known size, right? So now let's understand what a heap is. So imagine this is a heap, right? So how heap works is, a memory allocator will come into a picture. Let's say we want a storage on a heap and we have a size of a data, right? So now we will ask memory allocator that, hey, we have a data of this size, find me a place so that my data can fit over there. Now, so what memory allocator does is, it finds an empty space on the heap enough for storing that data and mark it as being in use, right? It has to mark it as being used, otherwise another one can use that location. So it will find a location that is enough for that size of data, mark it as being used, and returns back a pointer. Now what a pointer is the location where the memory allocator has stored their data, right? Now here is the important thing that I have told you on stack, right? I have told you that on stack, when we want to push the data, we must have data of a known size, right? Now pointer here has a known size data. So you can store pointer on a stack, and later when you want to access the location of the heap, you will just follow the pointer. So you can imagine a heap as a kind of let me just explain you the process at restaurant, right? So imagine, so heap works at that way. So imagine you entered at a restaurant and you have five peoples with you, right? So you went there to just pre-book the table, right? So as soon as you enter the restaurant, you will tell the receptionist that, hey, I have five people over here and I want a table. Then a receptionist will act as a memory allocator. It will find a table perfect for a five guys, right? So memory allocator works in the same way a receptionist work at a restaurant. So it will find a location that is well enough suited for the size of the data and mark it as being active so that no one can use that table or that location, and returns back a pointer that anyone can follow to access that location. So these are the two parts of a memory, stack and heap. I hope you guys have understand. Now let's move to the upcoming topic, and these topic will help you understand that topic, right? So let's jump on that. So the topic for today's video is ownership in Rust, and let's understand ownership. So ownership is nothing but a set of rules that are defined in a Rust programming language that a Rust program follows to manage the memory. So before moving ahead, we must understand how garbage collector work, and does even Rust have a garbage collector or not. So a garbage collector will keeps on checking for no longer used memory, and it frees them, right? It free them from the memory and while the program is running, right? And in some of the programming languages, a programmer has to manually allocate the memory and manually deallocate the memory after using it, right? But Rust follows a third approach. It governs by a set of rules, right? If any of the rule is violated, then the program simply won't compile and it give a message that, hey, you are not using the memory approaches correctly, right? This makes Rust unique from the other programming languages. And you see, ownership is a very new concept to a programmers, so it takes time to understand this. So I want you to get focused over here, right? So when you understand ownership, you will have a solid foundation of this topic that will help you become a better Rust developer. So let's understand what all ownership rules are. So as you can see on my screen, let me clear those. Let me write it over here. Ownership rules, right? Let me change the color. Okay, delete this. Let me change it to red, right? So let's say, so as you can see on your screen, I am writing down the ownership rules. We will discuss them one by one and later implement practically. So as you can see, the first rule is each value in Rust has an owner. So the second rule is there can be only one owner at a time. And the third rule is when the owner goes out of scope, the value will be dropped. Let's head over to a terminal, start writing code, and we'll step by step learn these rules. So heading over to a directory and creating a new project, let's say cargo new. I am naming this ownership. Heading over to a directory, opening it in neovim. Alright, let's head over to a main file, right? Now to understand these rules, let's first understand what a scope is. So you must be aware of the scope, right? So there are scopes in programming languages, but if not, let's understand them. Now to understand scope, let's create a function, add over here, right? It takes two values, integer values, and it returns an integer value, right? What it does is it returns x plus y, right? Let me call this, let result equals add 2 and 3. All right. So you see, now scope is a kind of area, right? So for this function and these variables, these braces are the scope, right? Again, if I define an empty braces over here, this will also be a scope. And let's say I define a variable a over here, that is 10. Now if I will use a over here, this will be the out of scope, right? Because its area has been finished, right? I cannot use a over here. So A was only valid until this scope, right? This opening and closing braces was its scope. So after that, A will not be accessible and neither a program will know that what is A, because A was only known and valid until this scope, right? So this is called scope. And after this, if we want to use A, then this term is often known as that A is out of scope. You must have heard, right? A is out of scope. So it is valid only in its scope, and if we want to use after this scope, then we will say A is out of its scope, right? A is only accessible and valid until these lines, right? These braces. So after which A will be out of scope. So important point to be note over here is, as soon as a variable goes out of scope, Rust automatically calls a function called drop. Now this drop function will let Rust know that A is out of scope and the memory that was allocated to A is no longer used, so Rust will free that memory. So what does Rust did is it implemented a drop function as soon as a variable goes out of scope, right? So always remember, whenever a variable goes out of scope or anything goes out of scope in Rust automatically calls a drop, which help us Rust understand that okay, we need to free that memory now, that memory is no longer used. So let's understand how variables interact with each other and how stack and heap works by giving examples, right? So to understand how heap work, okay, so let's, all right, this will ignore the warning for now. All right, so whenever you see an unused variable error in Rust, just like prefix it with underscore. Okay, so you see it's saying binding A is unavailable, so we will also comment this. I hope you understand that, right? How things goes out of scope and what Rust does if a variable or anything goes out of scope, right? It calls a drop method. Now let's understand how variables interact with each other and how memory allocation works. So let's create a variable x over here, give it a value 10, create another variable y over here, assign x to it, and let's print the value of x. Alright, and to diminish this message we will use underscore. Alright, so as you have guessed what is happening, we have simply created x, a value of 10, and copied x's value in y, and this is how stacks works, right? Stacks stores a value that have a known size, right? So x over here, x and y integers, they are simple and they have known size at the time of declaration, and they get stored in stack, and stack simply copies the data. There is no problem in that. Even after copying this x to y, I can print x, right? But in case of heap, we will see how heaps work, right? Now let's understand how heaps work by taking an example. So we will use a data structure string. So we'll use a string from, let's name it hello, and we'll create another string and we'll try to do something that we have done earlier for integers, right? We'll copy s to s2. Let's name it s1, right? So as you can see over here, I have tried to copy s1 to s2, right? Now let's do the same thing to this as well. I will try to print s1. So as you can see, I am getting an error. So let's understand what the error is. So it says that borrow of a moved value s1 occur. So before moving ahead in this error, let's understand how string gets allocated in the heap. So string has three parts. One is its pointer, for which the location is stored on the heap. The second is the data, and the third one is the length. Okay, so these three things are there available in the string. One is the pointer, the data, and the length of the string, right? So now when I do s2 equals s1, only the pointer is getting copied, right? So the entire string is not getting copied, only the pointer is getting copied. So because copying the entire string is an expensive operation, right? There are three things involved. First the pointer, second the data of that string, third the length of the string. So these three things, so copying an entire string is an expensive operation. So what Rust does is it only copies the pointer. Now we have a scenario where these s1 and s2, they have copied a pointer, right? So they both are pointing to a same location, right? The data is not copied, only the pointer is getting copied. So s1 and s2, they are both pointing to a same memory location. Now imagine a scenario if both s1 and s2 will go out of scope. So recall that thing that Rust will automatically call a drop, right? So as soon as S1 and S2 will go out of scope, they both will try to free a single location, right? So how can it's possible that they both are trying to free up a single memory? So there is a term associated with it in Rust that is called double free error, right? So they both are trying to free a single memory location. So that is why we are getting an error over here. So we call this step a move, right? We have a move occurred here. Now and with the line s2 equal to s1, we are copying the variable, right? We are not copying the entire data, we are only copying the pointer. So Rust understands that as soon as they both will go out of scope, there will be an error in the program. So it is giving us error early, right? That is the beauty of Rust. So that is why we are getting an error over here. So now what we can do over here is we can go for the expensive operations kind of thing. We can simply call clone in it, and if I do this, see, there is no error. Now that we have two objects, right, we have cloned entire object. So now Rust knows that okay, there are two different separate objects. Now there will never be a double free error, right, if they both goes out of scope. So these functionalities, fundamentals and rules will also get applied to function as well. So let's understand how. So for that, let me introduce another variable, let's say s3 of type string, right? And let's name it Ola. And let's introduce a integer variable z, let's say 5, right? For that we need to create a function. uh, how do we create a function? Let's first call the function random. All right, we'll pass s3 on it, right? Now we will create a function. So how do we create a function? We use a keyword fn random, right? It takes a string of type string. It will return nothing, only perform some operation. We don't know it, but we'll just do this. Okay, so you see, I passed s3 on this function, and if I try to use s3 over here again, I will also receive an error. Can you guess why? We just have understand this. Can you guess why s3 is will get an error? Because s3 has been moved, right? Now see how. See, when I pass s3 to random, inside random, as soon as this scope end, right, these are the scopes, right? So as soon as this scope will end, Rust will automatically drop. It will free up the memory for s3. Now the memory has been freed and I am still using s3 over here. You understand what I'm saying? I have created s3, I have passed this s3 on a random function. Now the function has been executed. So as soon as the function has been executed, will goes out of scope, Rust will call drop. Now the drop has been called, memory has been freed, and I am still trying to access s3 over here. So you see, these rules also get followed on functions as well. So Rust will make sure that as soon as the drops will call, it will free up the memory. So we will get an error over here. All right, so but let's see the case with integer values, right? So we have defined z over here, and let's call a random int, and we'll pass z on it, right? Let's comment this, it is getting an error. Let's save this first. All right, now let's create a function fn random int. It is taking an integer value, let's say a of type i32. It will also return nothing, but what the hell, man. All right, it will return nothing, right? So you see, now if I try to access z over here, will I get an error? Will I get an error? No, because variables uses stack and nothing special goes there, right? We only copy value, the value gets directly copied, right? So it goes out of scope, but it will always remember that z has 5, right? So from this you must have understand that these all fundamentals are called ownership. So let's understand how ownership will work on return type as well. All right, so let's work with the return type. Let's say let me clear these at first. Okay, let me clear this. All right, so we'll understand how ownership works in return type as well. So uh, let's say I have to define a function. Let's say it only takes the ownership. Let's say I am defining a function takes ownership, right? And I will define s1 as a string. Hello, right? So this function will only take ownership. All right, let me define another string over here. All right, and I will define another function takes and give back ownership. All right, now this function will take the ownership of s2 and return back another. All right, we will store that in s3. Okay, we'll print this. Now let's introduce function as well. So function takes ownership will take a string of type string and will perform some operations, right? And introduce another function as well, takes and give back ownership, right? Let's define a keyword of fn over here. It will take a string that has a type string. It will return back a string, right? It will perform some operation and return back str. All right, now we have an error that it takes ownership. Okay, let's pass s1 over here. Okay, so we will demonstrate each things, right? Okay, println, let's see. So as you know, s1 will definitely throw an error because as soon as I pass s1 in that, it the value goes out of scope as soon as the s1 ends. Now this doesn't throw an error because the ownership is passed and can also be transferred, right? I passed an s2, right? I pass s2, so the ownership has been moved to this function and it returned the ownership back to s3, right? So as soon as this goes out of scope, the ownership has already been passed and drop has been called. The memory of s2 has been freed, but s3 has an ownership now, so s3 will never get, so we will never get an error over here, right? So you understand ownership can be transferred, can also be passed, okay, on the function return type as well. So as you can see, s3 we haven't get any error, and on s1 we are still receiving an error. So how we can avoid this? So there is another concept that is called borrowing and references, right? So we don't have to necessarily always pass the ownership, right? We don't have to transfer the ownership. What we can do is we can pass the reference or we can borrow it, right? So let's say we have an s1, so instead of like passing the entire ownership, what we can do is we can simply use ampersand over here. So this way, as you can see, I have passed the reference of that string. Now that entire string is not moved, only it borrowed it, like, so this take ownership function, it borrows, and I have passed the reference. Now I am getting an error because I have used a string over here, but it is expected to receive an reference. So as you can see, now I have used the reference over here. Now the data is not like the ownership has been never moved, right? And to understand these topics in detail, I will highly recommend you to go to the official documentation of Rust, where you will have a detailed explanation with examples to understand how borrowing and ownership works. Now let's head back to the three ownership rules that we have defined earlier. All right, so the first rule is each value in Rust has an owner. Okay, so as you can see over here, whatever we define in Rust will have an owner, right? So currently, as you can see, s1 is the owner of this string hello, s2 is the owner of this string word, right? So everything in Rust has an owner. The second point is there can be only one owner at a time. So as you can see, currently S1 is the owner. If we haven't passes this reference over here, then the ownership transfer to take ownership function. So for that, let's go over here, right? So as you can see, I have defined a string word and s2 is the owner of that string, and when I pass that s2 to this function takes and give back ownership function, now the ownership has been transferred and this function is now the owner of that s2 variable, right? So the ownership has been passed. So there can only be one owner at a time, and when an owner goes out of scope, the value will be dropped, because again Rust will automatically calls a drop function. So here comes the third point of this ownership rules, that is as soon as the owner goes out of scope, the value will be dropped. So you see there are three ownership rules in Rust. The first rule is everything in Rust has an owner. Secondly, there can only be one owner at a time, right? And third, when owner goes out of scope, the value will be dropped, because Rust calls and drop function automatically as soon as things goes out of scope to free up the memory. So I hope you understand these three ownership rules, and if you want to know in detail about that, I highly recommend you to go to Rust official documentation. So that's it for today's video. I hope you like the video, and if you like the video, please give it a like, subscribe to my channel for awesome amazing Rust updates. So see you on the next one. Till then, keep grinding and stay happy.